Okay, part 2 of your test is tomorrow. I picked some of the sample problems from the review. The rest of them, again, are on your Polaris account, so you can check those and try a few other examples. So you need to be able to state the domain and range of a function that's graphed, identifying the x or y intercepts, find the intervals in which it's increasing, decreasing, or constant, determining the relative extrema if they have any, and whether the function's even, odd, or neither. So starting on the number 54 one here, the domain, remember, is the x values left to right. So the furthest left this guy goes is negative infinity. Then you can see there's a vertical asymptote at 0. So the function's domain is going to jump at 0 and then continue on the other side of 0 to infinity. The range from bottom to top, the lowest this function goes is negative infinity, and the highest it goes is positive infinity. And it's okay that, you know, both sides are the same. There's a break in the domain, not in the range. It continues. The intercepts, it has two x-intercepts at 1.5 and negative 1.5, so I'm going to kind of list them as plus or minus 1.5. There's a vertical asymptote at 0, so you can't have a y-intercept. It's not available to it. All right, increasing and decreasing and constant. So there's no constant sections. Increasing, it looks like 0 to infinity. Decreasing is negative infinity to 0. No constants. This does not have an extreme at points. Those are inflection points where it's changing concavity. So don't worry about the extreme points. These guys here are not maxes or mins. They're inflection points. And is it even, odd, or neither? Well, it appears to be reflecting over the y-axis, so we would say it is even. Okay. On this other one, the domain from left to right. On the left, it's an open circle at negative 3. It continues on to an open circle at 4. The range, the lowest it goes is negative 2, and it includes negative 2. And the highest it goes is positive 2, and again, it includes positive 2. Those are points that are actually included there. X-intercepts, it appears to be at a 1, and the y-intercept appears to be at negative 1. It is increasing from negative 1 to 3. Remember, we're only talking about x-intercepts when we're talking increasing, decreasing, and constant. It is constant from negative 3 to negative 1. And then again, it becomes constant at 3 to 4. There's no decreasing sections. And this guy is the extreme points. You would put, there aren't any extremes per se. It's more those constant sections that could be extremes. So these could be maxes or mins. So you would say all the points between from some x and negative 2 for x's between negative 3 and negative 1. And then you would say for all x's in the points x comma positive 2, for all x's in the interval 3 to 4. Okay? So those would be your extrema. And this is neither even nor odd. It's not even or odd. It doesn't reflect over the y-axis, nor does it, this is not a good spot, nor does it rotate around the origin. So we'll say neither, either odd. All right, the second one, we're talking piecewise functions. You've got to be able to evaluate these. So you need to figure out which function domain does the numbers exist. So -3 exists in the bottom function. So I would put -3 in that second one. 1 is a gate number, but the gate is owned by the bottom function. G of 3, 3 is bigger than 1, so it's going to be in the top. Those aren't real hard, you just got to figure out which domain you're looking at. F of 1, 1 exists in the bottom functions domain, so you would just say 2. There's nothing to plug in here. There's no x, it's a constant horizontal part of the graph. F of 2, 2 again is the gate number. In this case, the gate is owned by the top function, so I plug 2 in there. And F of 3, again in the top function, we put a 3 in there. Okay. All right. You need to be able to add, subtract, multiply, divide functions. You're going to have to do 2 of those. We're going to do all of them with this example. So F plus G, this already has common denominators. So you can just add the numerators. They want you to be able to figure out the domain for each of these. So the domain here is x cannot equal -1. If I were to subtract these, pretty much the same thing, but now we're just subtracting the numerators. The domain would be the same. Multiplying. So you're going to have to FOIL the denominator together. Okay, multiply the numerator together, multiply the denominator together. The domain, guys, is still the same. X cannot equal -1. Okay. If you're going to divide them, please make sure you're paying attention to which ones you're supposed to divide. If I do F over G, it's going to be 2x plus 1 times the reciprocal of G. I have an x plus 1 on the top, x plus 1 on the bottom. Those are going to cancel. I'm left just with 2 over x. But remember, the x minus 1, even though it gets canceled, it's still part of the domain. And then we have an additional x in the denominator, so 0 also cannot be used. So it's going to be -infinity to -1, -1 to 0, and then 0 to infinity. Okay, so we have the original domain restriction from this denominator, and we have this guy who's our new denominator when we had to flip that second function. So both of those are giving you your domain restriction. If I do g over x, I'm going to get the same idea. I'm sorry, g over f. So it's going to be x plus 1 times the reciprocal. Okay. Again, the x plus 1's cancel. And here you're left with x over 2. But when I flip that, I don't get a domain restriction with a 2. So our domain here is back to the original. It just can't equal -1. So take your time on those. Think about what's in the denominator. Is there something new in the denominator when I flip it? Okay. The original restrictions are there, and then you're going to flip, and there might be a new one there. And maybe not. All right. The next set is composite functions. Again, you got to be able to do f of g, g of f, f of f, g of f, or g of g. All 4 of those. So we're just going to do 2. I'm going to do all 4, but you're just going to have to do 2. So f of g. So my f function, I'm going to put in parentheses wherever I'm supposed to have an x. And then I'm going to input my g function. And remember, our domain, I would start writing right now. I know that I have a restriction. X plus 2 has to be greater than or equal to 0 because it is a square root. So just kind of leave that sitting there. Now, when I square a square root, the square root cancels. We can't do anything with this. You can't simplify that any further because you have that square root sitting there, which you can't combine with anything. So our domain doesn't have anything new to add to it. So it's just going to be the inputs domain. All right, let's flip it. Let's do g of f. So our g function, and then we're going to put our x function or f function in. There's no restrictions on that input function. It's a parabola. It's a quadratic. There's no restrictions. But when you look at the output function, you know, not that it matters that it's two different colors. You can't. That's not a perfect square. So you have to leave it like that. That has to be positive. Okay, so you simplify it to that. Now you need to look at what's underneath the square root here. So this can't be factored. If you do the quadratic form, you're going to get an imaginary. If you think about it and you graph it, this quadratic is never going to go negative. No matter what x you put into it, it's always going to be positive. Okay, you see it's above the x-axis. So the domain here is all reals. There's no x you can put in there that's going to give you this, that's going to make this piece negative. So the domain is all reals. Okay. All right, so that's a little bit trickier than what we want. Okay. We're going to do f of f. You're going to get the same thing going back to the last piece. If you do this, put this quadratic in the quadratic formula. It can't be factored. Put it in the quadratic formula, you're going to get an imaginary negative under the radical. So that'll tell you. Okay? F of f. So there's my f function, and inside I'm going to put in that. Remember, we're going to FOIL this with our little shortcut. So the square of x squared is x to the fourth. Multiply and double. You're going to get 4x to the third. And we're going to square that last term. Distribute over here. So that's what f of f equals. And the input function was a quadratic. The output function is still a polynomial. So our domain is all reals. Okay, last one, g of g. Again, on the test tomorrow, you're only going to have to do two. Either f of g, g of f of f, g of g. So, okay, our g function, if we go back up, is the square x. Okay. So we're going to take the square root of x plus 2, and we're going to put in the square root of x plus 2. Okay? We can't simplify that. It's just looking ugly, but that's how you're going to leave it. And then the domain restriction is that radical, the input functions. So again, that's got to be greater than or equal to 0. So x is greater than or equal to negative 2. Okay, so the input functions domain is going to continue. All right, so there's your composites. Then the inverse. So first thing we're going to do, make the f of x a y, and then switch your x and y. And your goal is to get the y by itself. So we're going to square both sides. That eliminates my radical. I'm going to move my 4 over. I need to get rid of the negative. So that's going to make this a 4 minus x squared. And then they want you to take the square root. So y equals the square root of 4 minus x squared. Okay. Remember, we want it to be a function, so we're just going to take the square root. We're not going to do plus minus here. That's it, please. Do not write that as 2 minus x. That's not the square root of 4 minus x squared. You're just going to leave it like that. Okay. So again, this we should have had up here. X has to be greater than, it's got to be positive x. It's got to be greater than or equal to 2 for that domain. For this to be 1 to 1. Right now, the square root of 4 minus x squared is not 1 to 1. So technically it doesn't have an inverse, but we're going to restrict it to the positives. So we're going to restrict this guy to your positive square root. Okay. On the other side, we're going to switch. So this is going to be x equals 1 over y minus 1. We're going to cross multiply to get that y off the bottom. And we're just getting, well, you know what? We don't have to do that. Cross multiply. Then we're going to divide by the x. And then we're going to add 1. Okay, so that is your inverse. You could jazz it up and put it as greatest common factor, if you, or greatest common denominator. So that would be your final answer if you got the common denominator. That would be it, our inverse. Okay. All right. Determine if there's relative max or mins. So we are going to graph this. Just like you did on your take-home quiz. Alright, so we graph it, and you're going to find all the maxes and mins. Doesn't appear to be one. To the nearest thousands. It looks like an inflection point to me, but let's look. Let's call it a max. Now I'm looking at what the y's are doing here. It's going up, 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 up. That's an inflection point. So this one has no max or mins. Not a good example to pick. So no max or mins. I know you guys know how to do it with your calculator though, so I'm okay. You'll be okay. Find the equation of the line. So we want parallel to this line. So the first thing you have to do is find the slope of this line. Remember, it's opposite of A over B. So it's going to be -1. And the parallel slope is the same. So we're still going to use -1. And we're passing through that point. So y minus y1, slope times x minus x1. So we have y minus 1 equals -1 times x minus 1. And that would be your line. If it is perpendicular, same thing, we need to figure out your slope. Slope is opposite of A over B. So the slope of this line is 1/3. We want to find the perpendicular slope. Remember, you're going to write the negative reciprocal. So we're going to use -3. So y minus the y equals the slope times x minus your x. there would be your line. That is perpendicular. Okay, find x such that the point x2 is 5 units from 2, -1. So the distance formula says you find the difference in the x's plus squared plus the difference in the y's squared should equal the distance squared. So subtract your x's squared plus subtract your y's. Remember, subtracting just means how far apart are they. So that's where we're getting the 3 squared equals the distance squared. Okay, so x minus 2 squared equals 16. We're going to take the square root of both sides. So remember, you're going to get 2 answers here. When you take the square root here, you get 2 answers, plus or minus. So our first answer is going to be x equals 6. Our second possible answer is x equals -2. Okay, so you're going to get 2 answers there. Find the point on the y-axis. So the y-axis point is going to be a 0 for the x, and we're looking for this particular y. So it's very similar to the other one. We're finding the distance that's equal distance. So the distance from this guy to 7, -4 is going to be the difference between the x's is 7 squared plus the difference between the y's squared equals, now you go on to the other point, the difference between the x's is an 8 over here squared plus y minus 3 squared. So you have to FOIL this one out. Remember our shortcut for FOILing, expanding that binomial. This is why I said the better you are doing the shortcut, the quicker your time would be. All right, the y squareds are going to cancel on both sides. So on this side we have 65 plus 8y. On this side we have 73 minus 6y. You're going to get the y's on one side. So we're going to subtract 65 on this side. We're going to add 6y to this side. So you have 14y equals 8. So y equals 8 over 14. I'm going to double check that. Okay, so that would be your y value. All right, if you have any questions, please shoot me a text tonight. I will see you on Thursday.